morning, everyone. This is Sandeep Giri. Good morning, everyone. This is Sandeep Giri. I'll be the instructor for this class. And please feel free to ask your questions using Q&A. Can you hear me clearly? Just reply by the way of QA window whether you are able to hear me clearly or not. What? Hello. Hi, Garbara. Please introduce yourself with a little bit about your background. Hi, Sheetal. Please feel free to answer your questions by typing because all of you are muted. Sorry. Hi, Shilpa. Please feel free to introduce yourself in a sentence or two. That will be great. Before we start the session,
Can we connect through the laptop also?
yeah, kindly mute yourself.
Hello?
Yeah, please mute your mic so that and communicate by the way of question answer windows.
No, I just want to check, can we use microphone
Uh,
or like the computer itself?
yeah, you can
We
use
can,
the
right?
yeah you can use, but your mic will be muted most likely. Okay, you can use the
But if
headphone
I
there
want to ask questions through my laptop,
by
so if I don't
questions
want to
window.
type through phone, I want, okay. Okay, then that will be unmuted.
What?
Okay, thanks. So I'll disconnect from my phone and I'll use the laptop.
No, yeah, either way, if your laptop has speakers and you are okay with using speakers of the laptop, it's good. Okay, but everybody's mic, whether it's telephone or the laptop, will be muted. Okay.
Okay, okay, got it.
Yeah, and kindly ask your questions using QA window. Good morning, everyone. This is Sandeep Giri. I will be taking this session. Please introduce yourself by the way of questions window. Can you hear me clearly? Answer it using the questions window. That is the way to communicate with the instructor, which is myself. Hi Tawfiq, please introduce yourself by answering the question. Using the questions window, you can answer, you can introduce yourself. Hi Sheetal, Sheetal is working as a project manager for a BI project using ETL Informatica, new to big data. Good, good, good. Hi Srinivas from Chennai. Good. All right. Hi Srinivas. So Srinivas is new to big data and is PPMG team. Great, great. He has great 18 years of experience. All right. Hi Sundaram. Sundaram is also from Chennai and is new to big data. Good. So probably because since it's a new field comparatively, therefore 90% of the people are new to this domain. Hi Sadasiv, and yeah, Sadasiv is works for Top's account as uh, offshore PM. Let me check if the recording is working. So the session is being recorded, all right, and this presentation will be shared with all of you, so you do not have to worry about taking screenshots or noting down, though noting down is a good practice, but you don't have to worry about missing out on any of this because I'll be sharing the presentation as well as the video. So keep your focus on answering the question and asking the questions, okay, as well as understanding what so you can keep the focus on the concepts primarily. All right. Okay. Okay. So Tafiq works as an analyst in AML banking domain. Oh, AML as in anti-money laundering. Good, good. Because I built an anti-money laundering system for a company called DE Shaw. All right, and is good, good, good. Hi Ankit. Ankit is from Wide with 5 years of experience. I'm new to Hadoop. Good. Hi Shwadhin. Great. So let's start the session now. If you can, all of you are able to hear me clearly? All right. All right. So, uh,
Hello, may I know who's the trainer?
just stay on the. Can you see my screen? I'm Sandeep Giri. I'll be the trainer. Please ask the questions or communicate with me using the questions window on your laptop in the webinar. Go to webinar. All right. Great. Swadhin is 8+ years of experience in Java and J2E. Great, Swadhin. All right. All right. So now we have a great set of team here, and let's start.
The voice is a bit breaking. Are you on speakerphone or something?
Yeah, I'm on speakerphone.
Yeah, I think not very clear actually.
All right, if you can't hear on the phone, please turn on the speaker or put the headphone on your computer, and then you will be able to hear. All right, because for me it will be impossible to hold the phone while I discuss. All right. Good. So I'm starting the session now. I'll be a little louder than the usual, so bear with me. Good morning, everyone. Everyone, I'm Sandeep Giri. I'll be taking the session on big data and Hadoop, and I'm a I'm from a company called No Big Data. We are primarily focused on training into big data technologies, the whole umbrella of big data technologies, and our all the sessions are online instructor led sessions. Okay, so here are a few of the highlights of what we do. We basically promote asking a lot of questions, and we primarily focused on answering the questions uh, as much as possible. Okay, so other than our these classes, we also have just now launched the forum, online forum, where we answer everyone's question as and when you have any question. Okay, because being able to answer the question is the most important, because manuals and documentation is anyway available everywhere. All right, so other highlight of our course is that we provide the lifetime access to the content. All the sessions including this one is gets recorded and gets shared with all the attendees, so that in case you have to revise or in case you have any doubts, you can go through the recording again and clear doubts. The biggest difference with our trainings and any other training is the cloud labs. So we have set up a big cluster online to which we give access to all our students, so that they can basically experiment hands on. And most of our students do the hands on as we are doing the discussions online. Like for example, in this class, had it been second third class, half of you people would be connected to our cloud labs and would be experimenting with our technology as I speak about something. So that is a very big advantage of cloud labs. You can access our cloud labs from anywhere, whether office or home or anywhere, and start working on it. You do not require any special computer for that. Your usual computer would be sufficient. Okay, and we provide 24 by 7 support via email. So if you have any questions anytime, just drop an email. Okay, now other than this, we provide a real life project based on your performance. If you have really done well in our classes, then we put you on the live project from the customer. Okay, so the way we operate is we work as a knowledge partner to lot of organizations. Okay, lot of organizations. Our few of our knowledge partners are Dell and Fidelity, and IBM is going to be from the February onwards. And so lot of such organizations, we work as a knowledge partner in that we help them hiring from our students, as well as we help them train their people into these new set of technologies. And we keep running the courses every all 24, all 12 months, so that as and when people join their organization, they put the candidates into our team, even if one candidate we accept as in our classes. Okay, and then we provide social visibility to all the candidates profiles based on if they are okay to publish their certificate. And we also provide the LinkedIn reviews, the actual review how you have performed. And we also do the mock interviews for you in case you want to switch a job or something. Okay, now about myself, I did my graduation from IIT Roorkee in 2002, and afterwards I joined a company called DE Shaw. DE Shaw is known for its data technologies. It's basically the cluster before everybody else. Even before Amazon and Google, DE Shaw had a cluster of 10,000 nodes, and that's what I worked upon. So somebody I was just telling about, I think Tawfiq was telling about the AML. So I built AML for a company called DE Shaw, and my anti-money laundering check used to run on multiple computers simultaneously to figure out if there is a fraud. Okay, if there is a money laundering happening. All right. So afterwards, I founded a company called Tbits Global, which was competitor to EMC's Documentum, and it's still running. And then in 2012, I joined in Mobi, where I built a couple of big data systems, including a recommender churning around 200 terabytes. Afterwards, I worked for Amazon for 1.5 years and built a competitor of Apache Storm specifically for Amazon. Okay, and I was responsible to take care of their image processing on the product detail page. So that's about myself. And in this year, early this year, we started No Big Data. Okay, so today we are going to discuss two things. First, understanding what exactly is big data, why now, and why do we need to learn it as of today, and then the various challenges, why those challenges, and afterwards the various solutions provided for big data. And then we'll pick one solution called Hadoop and understand how does it solve the problem faced by big data developers. All right. Now, in today's class, these are the things I'm going to discuss. In case we do not complete anything, we'll do it in the second session onwards. Okay. This session is complete, absolutely free for emphasis, and basically, it's a free course offered by No Big Data for emphasis. Only the first session. So before we start, let me ask you, what do you understand by big data? What is big data as per your view? Because you must have been hearing about big data for quite some time. So, so what is big data? What is it that you understand by big data? Okay, okay. Hey, please answer by typing in the questions window. All right, by because everybody is muted. I'm sorry for interrupting. Please answer by typing because there are 26 people in the session right now. Okay. All right. So I'll read out the answers posted by other people. So as per Swadhin, big data is unstructured data with huge size. Good, good. Sheetal's answer is efficient mechanism to store huge data volume. All right. Vikas says that data in big size, example terabytes, petabytes. Good, good. Srinivas says that data from multiple sources used for analyzing and taking strategic decisions. Ankit says big data is large unstructured data. As per Madan, it's large amount of unstructured data. Okay. Shudindra says that large chunk of dynamic data. Yogesh says data should give insights as per KPI. KPI, as for those who do not know, KPI is key performance indicator. And in other words, that means data should give insights as per needed. Abhilash says that big data is unstructured, huge volume of data that might get updated very frequently, used for analytics. That is Sadashiv. Sudhindra says that in terabytes or more. Okay. Aparna says unstructured data which is feasible to manage. Big data is all about any size, structure, any volume and velocity. That is Vikas. Excellent. So please feel free to ask, answer the question, ask the questions. It will be great to interact, and trust me, that's the only way to learn. All right. So, if I'm one way, if I'm the one only speaking, that trust me, it won't work that way. You will all sleep off. And Garbara says that working with huge volumes of data, excellent, excellent. So we have got a great, excellent, active class who is answering questions out of 26 people, 28 people, more than 15 people have answered. Excellent is still 50% people have not answered. All right. So, okay. Sundaram says big data is unstructured data which is updating frequently. And there is more. So, Shilpa, just mute your volume, mute your speaker, or anybody, if your mic is on, please turn your mic off because there might be echo. Because if any of you has the mic open, right, then there will be a feedback. Because I have both mics working, both mics on. One is of the phone, and other is of the webinar. If I turn off the webinar's mic, then the video recording will not have the voice, right? Therefore, I'm keeping both the on. All right. Susma also says that there's a lot of disturbance in the voice. So, in case you are facing a disturbance, please you can use the speakers of your laptop. Okay. Srinivasa's answer is data in real time. Okay. All right. All right. All right. So great. Great. So everybody has answered what is big data, and I'm moving on. All right. So as you all of you have answered, if I have to, summarize it and say it in my own words, the big data is nothing but data of very big size that cannot be processed using usual tools. And for handling such a big data, you require a distributed architecture. Data could be structured or data could be unstructured, right? So these are the four attribute of the data. These are the four attribute of the data. Okay. So first, the in very very simple words, big data is nothing but data of a very huge size, which you cannot process using usual tools, meaning your relational databases, your existing file systems, your those systems will not be able to handle that kind of data with that kind of requirement. Okay. Now, what do we do if you get stuck in such case? Mostly, such kind of problem can be solved using a distributed architecture. Then we say that it's a big data. Okay, and such data can be in any form. The fourth point is actually redundant, saying structured and structured. The only reason the fourth point is there because we always had been talking about data in terms of a relational form. Okay. So what does it mean by structured and unstructured? In structured format, we know what are the fields available in our data, that this is my first name, this is my last name, this is my middle name, and this is the age. So we have clarity about what are the fields in our data, as well as what is their data type. Okay, so if you have clarity about the data type as well as the fields, uh, the fields are fairly separated and there is a structure to the data, then we call it a structured data. In case we do not know, we do not have a differentiation between the fields, we do not know in what form our data is available or data is organized, we say that this data is unstructured data. All right. So then there is something called semi-structured data, which is between the two. In semi-structured data, we know the structure, but we do not know the data type. Okay. In semi-structured data is XML format or HTML format data. All right. So Shilpa is not able to hear. Can somebody help from the admin side? Amish is also having the same problem. So if you guys are facing that problem, probably you should switch to your laptop with the laptop's speaker. That will be a better idea. So those who are on desktop are actually able to hear clearly. Okay. So there are multiple people who are not able to hear clearly. If you guys are, I mean, from the training department, if they can fix this, it'll be great. So Susma, if it is possible, then turn on the speakers of your laptop, and then you will be able to hear it clearly. All right. So let me answer. Somebody has asked about semi-structured. Okay. So a semi-structured data, there are two extreme of the form of your data. In one, you know clearly and crisply that your data, these are the fields of your data, and this is the data type of each of your field, right? The classic example is our relational database, where we have a great clarity about each column and their data type, right? So that is called structured data. All right. Now unstructured data is just opposite of this one, where we do not know what are our fields, and we do not know the data type of each of these fields. We require parsing to convert an unstructured data to structured data. Okay. The example is, if you have used Apache server's logs. So in Apache server's log, there is the data is in a plain text file, and we need to convert it into relational database to make sense out of it. Or we need to figure out which what byte to what byte is our first column, from what byte to what byte is our second column, and so on. Okay. So that is unstructured data. Semi-structured data is somewhere between the two. Okay. Semi-structured is in the form, can be in the form of XML, can be in the form of CSV. In CSV, you know that the data is separated by comma, but you do not know the data type of your data. All right. Okay. So it was Sudhindra's question. All right. Good. So another question is unstructured data does not follow RDMS concept? Not really. So data can be in any format. It can be in the hierarchical objects kind of format. May not be. Okay. Let me repeat the question. Swadhin's question is unstructured data does not follow RDBMS concept? So answer is no, because in unstructured data we don't know really where is our data. Okay. So imagine that you have a big plain text file which contain your data, but you do not know in what format it is right now. Okay. So first you'll have to convert this into your relational format. In relational format there is no hierarchical, it's all flat, as in there are every data is in the form of a collection of tuples, and the way you form the structure, the way you correlate the data is by joining the data, right? So but unstructured data could be in any format. It could be in a plain text format, it could be in binary format, it could be in doc format, or it could be in XML format. XML format is generally called semi-structured data, because there we at least know the fields, not the data type. All right. All right. So hey guys, I will not be able to speak louder than this. If you have a laptop, turn on the speaker and put on the headphone. All right. Because by the end of 2 hours, it will going to be pretty tough for me. All right. So when we talk about big data, these are the four V's. These are the four V's that matter. All right. Volume, velocity, variety, and veracity. This is the classic definition as given by IBM. So the data could be in at rest, data could be in the motion. So this is the classic definition which IBM gave, and they keep on adding one v's to this definition, and they seem to have added one more v this year called value. I don't know how many v's it will become next time, but just to be on the safer side, when people are asking you about big data, other than giving the previous definition, this definition, where third point is the most valid point. Whenever your problem is complex and big, that that you require distributed architecture to solve. And what does it mean by distributed architecture? Distributed architecture means distributed architecture means multiple computers to solve your problem. All right, multiple computers to solve your problem. So that is distributed architecture. Okay. Hi Shabrinath, there are a couple of people who are not able to hear. Can you guide them how to connect? Shilpa is not able to hear properly. So can you help Shilpa if you're listening, Sabrinath? All right. So the first V of big data definition by IBM is volume. So the problem can become complex, as we talked about. Your data is so big that you can't handle using one computer. Can be due to the volume of the data. Volume as in the data at rest. Okay. How do we store the data? That is the main challenge. Okay. So for example, Facebook already accumulates so much of data every day. Where do they store such kind of data? So when storage becomes a big problem, then we say that by the because of the data at rest, because of the volume, our problem is of big data problem. Okay. Now, if you are not able to handle the load because of the velocity, when there is a lot of movement of the data, then we say that your problem is of big data is big data problem because of the velocity, because of the velocity. Okay. So Silpa, if you have the, let me just answer. Okay. Please use the laptop speakers if possible. Okay. Now, so let me, so when I say four V's of big data, it means basically the that because of any of these V's, there could be you will not be able to handle the data. Okay. Because of any of these V's, you may not be able to handle the data. Just a second. There are, just a second. All right. So the I was talking about velocity. So can somebody quickly give an example where there is no volume but there is a lot of velocity because of which the data gets complex? Just quick one example. So I talked about the big data can become a problem, or a problem can become a big data problem by the because of the volume of the data. The volume to be stored is so high that you can't handle it using one computer, because a single computer can only store a small amount of data. We'll go into the details in a minute. Okay. Share market data. All right, that's a good, Silpa. And yeah, so anywhere there are updates happening and a frequent updates happening, in those cases the velocity is high but the volume is not there. Imagine there is a stat counter on a website. Imagine the website counter. Every time a user hits that website, this counter increases by 1. Okay. And when the millions of users hit this website, there are million hits on this website, but it's only updating a single number. It's only updating a single number. All right. So that is when we say that our problem is big data problem, but because of the velocity in the data. So there are a lot of requests coming in but data is not accumulating a lot. that's that could be one scenario, or it could be both, volume as well velocity, because of which we might end up in having a distributed architecture and hence a big data. All right. Now, that was about velocity. Let's talk about something called variety. There could be a third case, even when your data is small, as well as there are not many requests coming in per second. There is no velocity, there is no volume. Still, you might have to use a distributed architecture, and and which is variety. Okay, so the variety is the third point, which makes your problem the big data problem, because it might be complex, it might be, your data might be in various kinds of format. The data could be in the maps format, it could be geospatial data, it could be images, it could be videos. So imagine this, so you have the data the of Karnataka, of whole state. Okay, as in you have the maps of whole Karnataka with all the details. Now you have to find out what are the places, that are lying, or what is the greenery available in various states, in various cities. What is the green patch ratio, or you just have to find out a path from one location to another. So even though your data is smaller, your number of velocity is not there, number of requests being handled is low, but your data is in a complex form of maps, it has multiple layers, it is three-dimensional data, and so on. Now, to handle such kind of problem, it may not be possible to use a single computer, because a single computer may not be able to help you, and therefore you will have to use multiple computers to solve such a problem, which doesn't even have a big volume, it doesn't have big velocity, just because of the complex structure of the data and the complex form of processing. You have to use distributed architecture, and and that's when we call it that our problem is a big data problem. Okay, so variety is the third reason, or third biggest reason to convert your problem to big data problem. Okay, now the fourth reason why your problem might become big data problem is veracity. What does it mean by veracity? Veracity means the data in doubt. And what does it mean? So you have your primary data somewhere, and you have various derivative data. Okay, so let's say you have the population of the world, that or let's imagine this. You have temperature data of the whole globe of each zip code. That is one data set. Now you have second data set, which is the temperature of each city of the world. Okay, so you had the first data as temperatures of each zip code, and before that you might have another set of data called temperature data on various GPS locations. Now all these three data set, one based on GPS location, other zip code, other city, right? You might be in a circumstance where you cannot you might be in a situation that you cannot decide that which data to keep and which data to delete out of these three data sets, right? One is on, you have temperature data based on GPS location. Second data set, you have temperature data based on the based on the based on the zip code, and third one is based on the city, right? Now all of these three data sets are right now look the same, but we need to do a lot of analysis to realize that only one data set need to be retained, rest of the two can be derived from the first one. right? But till the point we reach to a concrete conclusion, we have 3x data, 3 times data. And therefore this confusion due to you know secondary data, primary data, right? We might end up storing all three data sets, and hence we might require more space, more volume, and might be more velocity at times. And therefore, because of this confusion itself, we end up converting our small data problem into big data problem. All right. So that is fourth one. Okay. So this is how IBM has described the characteristics, the four basic characteristics of big data. Okay. So was I able to make any sense? Great. Great. Awesome. So the class is awake. I asked that question just to check if I have put you guys to sleep, and thankfully I have not. But looks like only six people are awake. All right. So moving on. So that was our definition in two forms. So the third point you should always remember: if your big data, if somebody tells you that I'm using on this computer, he's handling and processing big data using his laptop, and then you should surely say this guy is just bluffing me. Okay, because big data means a distributed architecture. All right. So Aparna is saying that can you give one more example for the veracity? So veracity is any say I gave you that V example because based on my own experience. So one of our candidates was doing churning of the data of temperatures of various places. So he first downloaded 2 GB data from somewhere, then 30 GB data from somewhere, then 40 GB from somewhere. Now he had like 5 data sets, and since he is not clear about which data sets to keep and which data sets to delete, he end up he end up converting a small data problem into a big data problem. Okay. So whenever you are in that kind of scenario, your data could be I mean, right now you are confused. Say you have three data set and you don't know which one to delete, or maybe all of these three data sets are useless. So till the point you reach to a conclusion that which data set to keep, which to delete, you say that your problem is of big data problem. Okay. Hope I'm able to make that veracity, because I'm sure the people who coined the fourth V called veracity also they did not have clarity of thought actually. I generally like these first three definitions, and they did the fourth V is generally added by IBM, and I don't know, next time V for vendetta will be added into this. And yeah, they have added value this time, and next time it will be V for vendetta types. And great. So the conclusion of whole discussion is that whenever your problem is has high volume, high velocity, or huge variety, and you end up using multiple computers to solve your problem, you say that you can flaunt that, hey, you are solving big data problems. All right. Yeah, this we can go with the first one, and this we could go with the second. The fourth we could also go with the first, any of the first three. All right. You're right. You're right. Now, data is at the end of day. it's either moving, I think it's in the form of electron, right? Whenever you connect a LAN cable, or if you are the data transmitting through the Wi-Fi, it's in the wave format. That's also the second property of the electron, right? Or it is static due to the polarity of the disk, hard disk. So either of those three formats we have. All right. Now, okay, just to check if you guys are tuned and if you are able to see my screen. So how many bytes are there in petabyte? Okay. So Gorbera says that it's 1024 GB. I don't think so. Probably you guys are not using Google enough. Okay. Good, good. You're right, Gar. This time you're right. 1000 exabyte. That is Sudhindra. Oh, no, no, not really. Ankit says 10 to the power 9. But 10 to the power 9 is GB, right? Sheetal says 2 to the power 64. Mm-hmm. I don't think so. So Digvijay says 10 to the power 15, not minus 15, right? It's 15. One, 1000 terabytes. Good, Srinivas. Okay, 10 to the power 15 bytes. Thank you, Suhas. Smita says 10 to the power 15. Perfect. 2 to the power 15. 2 to the power 15 is very small, Sushma. Okay, Utkarsh says 1024 to the power 5. Thank you, Utkarsh. Yeah, that is a nice way to answer. And yes, Swadhin says 1024 into 1024 into 1024 into. So you missed 1024. Okay, all right. 2 to the power 15. Thank you, Sushma. That's right. 2 to the power 50. Yep. Awesome. Awesome. So everybody is awake and everybody's answering. Excellent. Excellent. So now, so this is the general answer. If you used Google, this is the answer you must have got. And I also picked it from the Google. Okay. But the better way to remember it is in this format: kilo, mega, giga, tera, peta, exa, zeta, iota. So each one is 1024 times the previous one. So kilo is 1024 bytes, mega is 1024 kilo, and so on. Right. This is probably the good way to remember it. All right. And yes, you can generally you can just count till zeros. I mean, considering 1000 also will do in most of the time. Okay. All right. All right. Great. So why do we need this kind of information? Is because whenever you know your capacity, say you have this much disk, so on an average you can get 1 terabyte of hard disk easily in the form of the normal magnetic hard drives, but you can't get 1 terabyte kind of hard disk in solid state. So most of these specifications are in GB, TB, and petabytes. And when you are doing your calculation, back of the envelope calculation, these metrics come into picture very quickly. Okay. They make you, they help you in doing a quick computation if you have this a clarity on this table. Okay, so now we talked about two things. Okay, we talked about two things. First one was when when we have huge data, which is volume of data, and when we talk about volume of data, we are actually talking about storing that data. So do you think, we gave you two definition. First, what is 1 petabyte? Second, what is a big data? Big data is something for which you require distributed architecture. As simple as that, in very, very simple. Okay. So, do you think 1 petabyte data is big data? It's a difficult question. Okay. So, feel free to answer this question. Okay. Yes or no. Or maybe. Or in very, very simple words, if in your organization your boss asks, hey, we need to store 1 petabyte data, so your answer should be ki, hey, we need big data solutions, or you can handle it using your existing architecture. Aparna says maybe, and Madan says maybe, and yes, Swadhin, Aparna, and Madan, and Utkarsh, and Shilpa says maybe. So in case you think maybe, that means you have some way to handle 1 petabyte data using your existing architectures, right? So it would be great if you could just write it down that, hey, how would you solve 1 petabyte storage without using a distributed computing? We are not even thinking about querying the data. Before querying the data, before doing anything with this data, we'll have to store it, right? Storing this data is inevitable. Okay, querying is secondary. So do you need a distributed computing for 1 petabyte data? The answer is yes. The answer is yes. So even if you bought 5 terabyte hard disks, still you would require 200s of those. And to connect 200s of those hard disks, either you go with the traditional network file system where you will face a lot of challenge in the storage, or you go ahead with a big data kind of solution. We'll go into the details into how do you implement such kind of mammoth storages with the perfect usage of all the hard disk and all the I mean at the lowest price with the existing hardware itself. Okay, we'll go into the details of that. All right. So my answer is yes. Those who have answered maybe or no, we will discuss after some time how do we go ahead with this. Okay. Now this is the classic graph which basically depicts the growth of digital and analog data. What is analog data? Analog data which was there in the form of magnetic tape drives, or you remember those floppies. So most of the analog data is now has moved out, has been on the decrease, but the digital data suddenly exploded in 2002. 2002 was the beginning of the digital age, and by 2007, as per estimates, there were 280 exabytes of data worldwide. Now you can imagine, and this growth is exponential. It is not linear. Okay, it is not linear. You'll have to plot the graph instead of a straight line to figure out the figure out what would be the data as of today. Okay. So Seetal's question is, many large banks like JPMC have a lot of transactions and still they have not started using big data. Okay. So when they talk about these many transactions and so much of data, most of them are already in the form of their own custom solutions, which are not that, that efficient. So for example, at Disha we had our own cluster in 2002, and we had our own solution. They effectively were big data solution. Okay, but now, well, the moment we realize that there are alternatives as published by Google, the ones Google is using, I mean, lots of people are moving to it. I'm not sure if Disha is moving, but other similar people are using. So we cannot say that large bank have not started using big data. They had big data. It's just that their solutions are older. Okay, the solutions are older, which are not that efficient. So, yeah, JP Morgan definitely had a lot of data similar to Disha. I know for that fact. And they had a distributed systems in place to handle that kind of data. It's just that they have not moved to newer challenges. We'll talk about this in a minute, okay? We'll we'll talk about what kind of systems most of these people had and how that could be made far better by using the today's solutions. All right. Now, before moving further, so this previous chart showed you that there was something happened in 2002 because of which there was sudden expansion of digital data. And what is that happened? The basically two things happened. First, the hardware devices got cheaper, better, and faster. Cheaper, faster, and available. Okay. Uh, so every hardware manufacturer had this target called, it has to make the device cheaper, faster, and smaller, right? So that's the first thing happened in 2002, in 2000 or 2002 or something, when I started my career. Now, second thing that happened at that time was the internet connectivity. Suddenly there were newer protocol, newer network equipments, newer form of transmissions, because of which transmitting the data from one place to another became very easy. And at every transmission there is a data generation. Say, for example, we are conducting this audio video conference. Right now I am the only one speaking, right? Now this recording is being uploaded, say at the end of three at the end of this session there will be 3 GB of data. But if you see, the total transmission will be 3 into 32, right? Right now we have 31 people in this session, so basically 31st is myself. So at the end of this session, total transmission of the data is going to be 93 GB. Okay, because I'm assuming that this single transmission will be around 3 GB or maybe 1 GB. So effectively 31 GB data at least is going to get transmitted during this session. And that is the reason why internet, why all of this basically multiplies the data, right? So two things happened. First, connectivity. Second, devices. Okay, and those are the two reasons why the data expansion, lots of people now, because of the devices available so easily, lots of people generate a lot of data, right? Everybody is running Google Hangouts, everybody is having sending messages, and everybody is forwarding all the jokes all around. So yeah, so since the devices as well as connectivity, both of them together has made this big data handling data so much bigger than as it was earlier. All right. Now that was the reason why we have so big data. Does anybody has doubts about these two things? Because after a lot of analysis, these are the two things that have come out the reason for having so much of big data today. Okay. Having social network and all of those things is secondary because that happened because you had hardware. All right. Make sense to you guys? Now moving on. Any questions till now? Good. Good. So no questions. So I'm assuming either I'm explaining really well or I'm completely confusing it. You. That's the reason you don't have any questions. Is Teradata just another tool for big data? Yes, that's right, Digvijay. Okay. Thank you, Srinivas. Thank you, Sadasiv, that you are finding my explanations clear and great. All right. Now, what makes handling such a big data or handling so many requests the bottleneck? Or let me put it the other way, what makes handling data possible? And and because that's the one which will give you the clarity on why something becomes bottleneck. So we'll talk about this. So when we talk about computing, right, we all studied this. So when we talk about computing, the first pillar is your CPU. CPU is basically the flip-flop, the digital circuit, the electronic circuit, which based on certain instruction, it it understands the instructions and take the action. Okay, it reads the data from memory, puts the data back to the memory. That is what the the processor does. Okay, so the faster the processor, the faster you will get the output. Okay, there is a straight relationship between the processor and the output. Okay, but processor alone is not the criteria. Processor works in conjunction with the memory. If your memory is huge, okay, processor is going to be able to read a lot of data quickly from the memory. Okay, if the memory is smaller, then first processor will put the data into the memory, which will take the main time, and then you will be reading from the memory. And second criteria is how fast your RAM speed is. Okay, when I talk about RAM or memory here, it means L2 cache, L1 cache, all of that cache you have heard about. Okay, L2 cache, L1 cache are faster than the normal normal RAM normal RAMs. Okay, so here memory means RAM and L2 cache, L1 cache, everything. Okay, let me make it a point. Okay, now third thing which makes the data, which results in the speed of the data, is your hard disk. The bigger the hard disk, the more data you can store, right? But if you have faster hard disk, it's even better. Okay, for example, solid state hard drives are faster and they have the lower failure rate, so they make for the faster computing as compared to the normal hard disk. But solid state drives are comparatively smaller. Okay, and they are costlier also. So disk is another ingredient when we or another pillar for the computing, right? Now fourth one is network. Network is something we realized lately. Okay, so when your data keeps on growing big and you can't store on one computer, you move it to another computer. So if your network is slower and your data is lying on another computer, you are going to have a slower output. And therefore, network is a big pillar when we talk about computing, right? Because data reading can happen from RAM, from disk, and from the network. And if any of these four things are slower for you, then your overall computing is going to be slower. All right? Now, the conclusion of this discussion is that there are these four essential criteria for computing. Any of these can make your processing slower. And when we talk about big data, any of these four things will become the bottleneck in your usual processing, and therefore you will require distributed architecture. All right. Now imagine this: you put one more computer will come with all four components. Remember that. If you are increasing the CPU of one computer, then your RAM might become the bottleneck. In case you are increasing RAM, your disk might become the bottleneck. In case you are increasing the disk, your read write can become the bottleneck, and so on. Okay. All right, let me just turn off my. Okay, let me, if I can somehow mute all the notification for 8 hours. Okay, now, so any of these four things will become the bottleneck, and that's when you will require another computer. Now see this: if you put one more computer, you'll get one more processor, you'll get one more RAM, and you'll get one more disk, and you'll get a bigger bandwidth. The wire has become doubled. So therefore, if you are able to distribute your data in the best case scenario, you will get more than 2x times of output in the same time. More than 2x, remember that. Okay, it's not simply 2x, because all of these four components have doubled. All right, all the wires that were carrying electrons have also doubled. Remember that part. So whenever we go for distributed computing, it's not just doubling the ability, it's multifold. We are doubling our multifold. We are multiplying our ability to process the output, process the data, and get the output. All right. So these are the four things. And whenever we talk about things, you think about which one of these four is getting bottleneck. Okay. So because of the volume, your disk becomes the bottleneck. Because of the velocity, your RAM and CPU becomes the bottleneck, and the network also becomes the bottleneck. Okay. So that's another way of looking at the data. All right. Any questions still here? Now the next point is that the examples of big data. Okay. What are the three few examples of using big data as the solution? So Swadhin's question is, as I understand, distributed means we can remotely access. For that also we need one machine. Okay. So no, distributed does not mean remote access. Okay. Distributed means distributing your computing to multiple computers. When I say computing, it can be storage or processing or handling, whatever you want to say. Okay. So distributing your computation to multiple computers is what is called distributed computing. Okay. Remotely access is saying that cloud. I'm accessing something which is there. Somebody else's computer is the cloud for you. It is as simple as that. So, okay. So let's not confuse the cloud and the distributed computing. Okay. So basically, when we say cloud is somebody else's computer, as simple as that. Okay. When we say Amazon's cloud is basically Amazon's computers. Okay. Now, what is commodity servers? Thank you, Yogesh, for that question. A commodity server is nothing but a server not with the classic server kind of specifications. When we say server kind of specification, if you see all those computers you use, they come with 4 GB RAM, 2 GB RAM, and 8 GB RAM. While if you see the servers which people buy for buy for their data centers, they come in say 32 GB RAM, 64 GB RAM, and so on. Okay, so that kind of hardware is generally server grade hardware, while the one which you are using, your laptop, your PC, your home PC, all of that is a basically your commodity hardware. Okay, so like for example, when Google launched initially, they actually borrowed everybody's small hard disk. They bought the small hard disk from the students in their university. So that is commodity hardware. Okay. Yeah. So good question, Ankit. Ankit says the Aadhaar actually contains mostly structured data. In this scenario, is big data better than conventional DB? Yeah. So see, Aadhaar has got a storage also, right? Now, if you did do a little back of the envelope computation, the kind of data the Aadhaar is going to store, if it goes beyond the abilities of the traditional databases, then you will have to go for then you will have to go for the big data. Okay, the computation in the conventional database, in my opinion, is far easier than what we have in case of big data. So in case of your data is smaller, stick to the stick to the relational databases. In case your data is bigger, in case of say, as I talked about, if you have few terabytes of data, it's actually wise to move out lots of data to big data solutions instead of overloading your relational databases. Okay, so in case of Aadhaar, they also took that call, and some of the portion is in the relational format, while rest of the data which is not, which is the huge volume data, has been moved to the big data solutions. Okay, they actually use Hadoop. Okay, all right, was I able to answer, Ankit? So Sheetal's question is semantic web applicable for big data? Answer is yes and no. It all depends on how semantic web. Okay, and what do you understand by semantic web? Okay, and it also important to understand what kind of processing are you doing when you say that your application is semantic web application. Okay, all right, and everybody has the semantic web has got a different definitions. Okay, but most of the thing I understand from semantic web is the semantic search, which is on various kinds of attributes of data, and lots of people end up using big data solutions to solve their that kind of domain specific semantic web solutions searches problem. Okay, now let's talk about, so these are the few examples of big data customers. You have government who does the fraud detection. You have, okay, before that, there are, these are the four examples I would like to describe one by one. Let me I skipped this slide. How and why lies become, okay, okay, we'll talk about that in a minute. Digvijay's question is how and why healthcare and life sciences companies become big data customers. Because in simple words, when you deal with life sciences problems or healthcare problems, the data is huge. Till then, people had an excuse that they are not able to handle that data. We don't have a solution. Okay, people were hoping for, we'll buy a couple of supercomputers and try to solve the problem. But supercomputer is just hardly 2 to 3 times faster than the normal computer, or maybe 10 times, not the 1,000 times faster. Okay, but a cloud or I mean a big data cloud, it can be as faster as 10,000 times the normal computer, right? So therefore these life sciences and healthcare became the, they had no other way to solve their problem. Do I make any sense, Sheetal and Digvijay? Good. Now let me talk about a bit about recommendation engine. A recommendation engine is nothing but it's like me. I met you and you told me about the movie, your movies, and I told you about the movies I like, and we say, oh, we are so similar, and therefore we start recommending, have you watched this, have you watched this, have you watched this, and then we figured out that, oh, we are quite similar in our movie habits, and let's take the recommendation from each other. Okay, so that's a recommendation. Now, same thing can be built if you have millions of users and you have their information, their background on what kind of movies they like. Okay, so if you look at Amazon's website, you can see that they give you that people who liked this also liked this. People like you also like this kind of things. So that is recommendation. And the bigger data you have for processing for recommendation, the better results you will get. If you know that 98% of the people who like Matrix also like Jurassic Park, okay, which means you can safely give this Jurassic Park recommendation to all the people who have mentioned that they like Matrix movie, right? And when we say 98%, right, if you are doing this percentages over, you have just got three data points, right? And you say out of three people, two people like this, and therefore I'm going to give this recommendation. It does not make much sense. It could be a pure accident, right? But if you have big data, if you have say 50,000 people, out of 50,000 people, 49,670 people liking a particular movie after liking XYZ movie, that means there is a strong correlation. Okay, so therefore when you have the bigger the number, better is the result of recommendation. Smaller the number, the result is going to be very skewed. Okay, all right. So therefore recommendation makes all sense only if you have a huge data in place. Therefore therefore whenever you are building anything customer facing, try to keep as much as logs of the user behavior, so that at least you can give them the recommendation tomorrow based on their past logs, their past behaviors. Okay, And so I built recommendation engine for a company called InMobi, where we used to InMobi displays the ads while you play the game. Any game you play, at the bottom you will see the ad either from Google or from InMobi. Okay, so instead of showing ads, whatever showing is based on your history, what are the games you would like, and that actually worked pretty well, right? So that is recommendation engine, and recommendation engine is probably the entry point into this game. We will show you in one of the exercises on Mahat how to build a recommendation on the top of the movies details of various individuals, and how do you churn that. Okay, as an exercise I will show you that part. So that is in session number 8, called Mahat. Mahat is basically the kind of machine learning solution for on top of Hadoop. Now, second problem is ad targeting. Ad targeting may not make much sense to you. So let me just move to search quality. So search quality is an interesting idea because few years back, people thought that search problem is largely solved even in the case of the smaller organizations. Okay. For example, in case of Tbits was basically a document management system, and when people search for a keyword, we have to show the users the various document related to that keyword. Now, when I sat down and we sat down to build a really good search solution, we thought that we are don't need a big data solution. We just need to handle at most 100 GB of data, or maybe 200 GB of data, right? Now, but when we looked at the user's behavior, we realized that we need a tremendous improvement in our search quality. And what are those improvement could be? Those improvements are very interesting, and if you look at those improvements, and actually Gmail served as my ideal for building a search, right? So you search on Gmail and they give you a beautiful recommendations. Did you mean this? Did you mean that? Did you mean, do you want to write this? And that, for doing that kind of recommendation and for the doing that kind of searching, say for example stemming, what does it mean by stemming? Putting s or es at the end of the word. So when I look search for friend, it should also give the result for friends. Okay, so that is stemming. So you have got stemming, you have got recommendation, as in if you have a user type the word by mistake, you should give them recommendation. And then you have to figure out this automatically the synonyms from all across the world. What does it mean? Say you are looking for blue dart, right? Now there are at least 50 ways people can write blue dart. Okay, people can write at least blue dart in hundreds of formats. Now to figure that out, to build that kind of dictionary saying blue dart can be in these format: blue space dart, blue dash dart, blue dart continuous, blue dart dot, and so on whatnot, BLOODAART, blue BLUE, and so on. So to improve that search quality, you might have to crawl the internet to build the dictionary, and for that you might require a big data solution. All right, similar is the case of sentiment analysis. We generally go through a sentiment analysis in one of the sample projects, and we make sure that you learn the sentiment analysis as simply as quickly as possible. And basically what does it mean by sentiment analysis is understanding how the world has responded to a particular event. That event could be your brand promotion, your launch of your newer campaign, and so on, right? So, for example, what were the behavior of people when they looked at uh, before and after the release of movie called Iron Man 3 or Spider-Man X, whatever. Now, how do you do that is you collect the data from sources like Twitter, then join that data with the dictionary of sentiments. Dictionary of sentiments as in able means potential means positive word, and bad is a negative word, and it sucks is a bad word, and so on. So you already, these dictionaries are available from various kinds of sources. So you have a dictionary, you have downloaded all the tweets with respect to your brand, you join these two data sets and tell that this is the summation of each of the sentence. Okay, so this is the sentiment, this is the overall sentiment of the people towards your brand. All right, so that is what is known as sentiment analysis. The example I have given you about sentiment analysis is very, very simple in the sense that it just does not understand the sentence. It only basically goes keyword by keyword and finds out whether this keyword is negative or positive, and then sums up all the values of the keyword in a sentence, and then say this particular sentence is negative about it us, this particular sentence is positive about us, and that's all. Okay, so the sentiment analysis is one big use case, and we will actually go through one sentiment analysis example during the classes. Okay, and we'll also give you one project in which you'll have to do sentiment analysis and build a recommendation. All right, and sentiment analysis also requires big data. The bigger the data you have, the better the results you will get. Okay, so similarly in case of telecommunication, these are the things various telecommunication companies are doing. Okay, and these are the actual use case where people churn terabytes of data to give the results, or hundreds of terabytes of the data to get the results. These are the few things which normal relational databases do not do a great job. Okay, now these are the users of Hadoop, and that is the probably the coolest way to find out who are the big data customers. So bigger the font, the number of Hadoop nodes or number of computers they are using on which Hadoop is running are more. So Yahoo is using maximum number of Hadoop nodes, and while others are not. Node means a computer. Okay, so and all of these out of this there is, say for example, AOL is smaller. They have only maybe 20 computers. Yahoo has tens of thousands running Hadoop. All right. Now, these are the 10 common myths about big data. You are going to ask me this, but let me explain to this. So, big data always means the data or above or in the range of terabytes. No. Sometimes even gigabytes of data ends up becoming big data. As I gave you an example of maps, the 200 GB of maps will be impossible to handle by a single computer if you are doing a complex processing of that map. Okay, so for example, all I was trying to do is based on one of the I got the data from one of the prominent taxi guys. Okay, the data was in few hundred GBs. Okay, it wasn't in TB. And the idea was based on the GPS location of these cabs, which cab was where. I was trying to predict the state of the roads in Bangalore. Okay, so I had plotted a chart showing a clear indications that this is where the cabs get stuck mostly. This is where the cab moved very smoothly. And these are the times of the day, in what location, what is the speed or the acceleration of each car. Because I have the position, I can compute the velocity. Because I have the position, therefore I can also compute the acceleration. So even though the data was 200 GB, it was basically a big data, because I can for sure say that handling that kind of data is beyond the imagination of the normal systems. Okay, I mean the kind of computing I was doing over there. Doing okay. Now, second excuse which I get is that, hey, it's about social media and it doesn't apply to me. No. As I talked about search quality, even if you are building a simple intranet search solution, if you really care about giving a great experience to your users, you would have to build a great dictionary. And to build that great dictionary, you will have to go through the various kinds of corpus of the data from the world. Okay, and the corpus of the data, for example, is 500 terabytes of plain text from all across the website, last year's data of the whole internet. So it's not about only the social media, it is the real work. Okay, and it does apply to you. It's just that since you do not know how to handle such data, you try to ignore, you keep on ignoring that, hey, that kind of data we can just zip or delete the old data. That's the common way. Okay, okay, we can just zip the data or delete the old data, right? That's the thing which we have been doing mostly. But that's not the right way of doing things. The bigger the data, the more lucky you are. Okay. That should be the attitude. Now, the other thing, third thing is it will replace enterprise data warehouses. No. It would not replace EDW. EDW is for smaller data, smaller as in hundreds of GB data, up to hundreds of GBs data. And it's good, it does good till the point the data reaches there. Okay, and there are classic very big benefits of having enterprise data warehousing. You cannot have this or that. You both big data solutions as well as relational as well as EDWs will coexist happily, and people are making solutions like Hive which make you communicate between the two islands. Okay, your enterprise data warehousing and the big data solution and the relational databases. So people, like for example Hive, there are more people coming up with newer solutions which make you communicate across these systems. It is just a buzzword, it has no practical application. Okay, so in my personal experience itself, I have seen at least five, I have actually built five solutions, so it does have a practical application. When it comes to handling big data, it you cannot you have no other way out. Okay, either you choose to ignore the older data or choose not to collect the data or choose to solve problem only based on few data segments, and or you build really good solution on a very large user base. Yeah, so Srinivas is saying, are you saying that big data is supplement to EDW? Yes, not supplement, they can coexist. If you need big data you can use it. Okay, but in general you need to keep your eyes open that to understand that big data solves really interesting problems. I mean big data solutions solve, or you will solve, once you understand the utility of these systems. Okay, all right. Now, fifth thing is a new concept. No, big data, as I told you, it has been for ages. It's just that we gave it the name now. Earlier, it was known as either in the form of distributed computing or cluster computing, cloud computing, right? So, big data is just a new name given to the old bottle. All right. Now, it will be the future. No, it is the present. Okay, it is the present. It's just that few companies who understands their data, who understands that the industry, who understands the problem, they have moved. while others are catching up. Now, is expensive? No, it's not expensive. The technology is cheap. Hadoop per se is absolutely free. It is just the knowledge which is required. Okay, so if people learn, all of these technologies are open, all of these technologies are free. This is not those days where companies like SAP would happily charge people for even the books. Even for an online PDF they would charge people, right? Even Microsoft used to do that. That game is over. Now all of these technologies are open, all of these technologies are available. If you want to use Hadoop in your organization, it's absolutely free. Hadoop has got Apache license, which permits you using the solution for free and absolutely free without any legal foundation in your production environment. Okay, just don't sell only Hadoop per se. That's what they don't allow. Okay, if you just starting selling Hadoop and start calling Sandeep Giri Hadoop is here, this is what we charge, that is something not allowed without any additional add-on. So so the technology stack is, and third thing is hardware is same hardware whatever you have as of today can be utilized, and that is the prime assumption in all the big data solution, that it will use any hardware you want it to run on. Any hardware or software landscape is okay with almost all big data solutions. So Hadoop runs on Windows as well as of today. Now you have got, so any hardware is consumed, any software is consumed, so there is no acquisition cost of hardware or software platforms. Second, the software itself, most of the big data solutions starting with Hadoop, MongoDB, they're open and open source and free, and that makes them very very different and very very powerful. Okay, so and similarly the documentation manual everything is free, only there are people like me who help people learn all of this at an accelerated manner. Those are the only people who charge something for things. Okay, so so effectively the big data is not expensive, it is fairly cheap. All right, now it is up to you. All right, is for data scientists only or is magic? No, it's not only for data scientists, it is for everybody. And it is for everybody or is magic? No, it's not magic because okay, so whatever data scientists do to figure out various kinds of things, they make it available as of today in the form of libraries like Mahat makes it possible for you to use those advanced algorithms just as a library. And that is the beauty of today's world, right? People from across the world are contributing and giving you this beautiful library for free to do your data churning, right? So effectively, it is not for data scientists. Data scientists is just building those models and building those algorithms and making it available to you. It is your duty to use those algorithms and churn your data. Okay, and using the algorithms is like fairly straightforward. It takes like 10 minutes to give a demonstration on recommendation engines. All right, we have enough hardware, we do not need any more. As I told you, it's not about hardware. Any hardware can run almost all the big data solutions. We will build it when we need it. This is probably the biggest myth I have seen. Now, so what happens when people tell me that, hey, we'll build this big data landscape when we need it, right now we don't need it. So they do not build a place for massive storage of data. They have the storage of data centrally, but they have not built a massive, they have not told to all the developers, hey, we have got enough space, feel free to store as much of as information about the user as possible, right? Which means that The developers, the people, they will not store the older data. They will not keep the data such as the logs of the user behavior or debugging information about the app. Now, because of which, tomorrow when you plan that, hey, I need to do some sort of user behavior insights, at that point of time you'll realize that, hey, I don't have I don't have my users' behavior. My developers did not log those behaviors of past 10 years. And hence my the data which I have is very small, maybe 1 year's data, and past data we have just dropped because we thought we did not need, and because we the cost of storing this data was very high, and therefore we can't build these brilliant recommendations. And and I so wish that we could have stored the data. That is what actually happens. So start building a massive storage today. Even if you have no plans of building a computing engine, but you should start building the massive storage today. Okay. And big data is not all only about Hadoop, it is about many similar solutions. Okay. Okay. Now Yogesh's question is, does analytics is about big data? Okay, good point. So analytics is just one part of the big data. Okay. Whenever you are running analytics on top of a big data, on top of a humongous data, or if your analytics is generating enormous amount of data, right? So in those cases we say that it's a big data analytics. Actually, complementary is the right word. Yes, you can say it's a complementary, but in my when we say complementary, it does not mean that big data requires EDW. Okay. All right. Now, EDW legacy systems, big data outside access. Um, mm, you can also look at it that way, Srinivas. So EDW, not really. Even if you are creating fresh data, for which you do need to do a lot of you have a small data but you want a little bit faster access, and it's a relational data which requires transaction. I would strongly recommend that you keep your EDW in place even if it's a new data. Okay. So Sushma's question is, so Hadoop is available open just like Linux OS. I'm comparing with what I Yes, it is exactly like Linux OS available, just the licensing is different. The licensing of Hadoop is little bit more flexible than GPv3, GPLv3, which is what I think Linux is now. Okay, so you are perfectly right when you say that it is open just like Linux. And similar to Linux, there are three, four companies who provide customizations on top of open source. Can we visualize big data to be a superset of all the middlewares? If not today, for a long-term perspective. So Srinivas's question is, can we visualize big data to be a superset of all middlewares? If not today, may or may not. Okay, so it's not really a middleware. It's a basically a humongous storage and a compute engine on large scale. Okay. Every middleware has their own format and has their own benefits. Okay. So the way it would happen in the long run is most of the middleware which you use are going to support Hadoop or HDFS or similar big data storage and computing systems. Okay. For example, earlier the algorithms which middlewares used to provide, now they support the compute engine as well as the big database. All right, makes sense, Srinivas? Okay, God's question is, what is the role of a data scientist? So, data scientist is a person. So, okay, first of all, let me take a step back. So, everybody has got their own definition of data scientist. I met couple of people who have not handled bigger than few GBs of data, and other than R, they didn't know anything. I have also met people who are data scientists who have dual PhDs into electrical and computing, and they have a machine learning as a specialization. So those are data scientists. So first, data scientist is a big spectrum, right? It's a big spectrum. But as an ideal, data scientist role is to look at the data and figure out ways to analyze or solve to analyze or build an algorithm to give you the correct insights, right? Say for example, give me the ratings overall rating of a movie based on all the people, right? You have got humongous ratings by various people. So developers role is to make such thing possible, build such a system. Now if you do the average, simply average rating of the movie, then what will happen is, if there is only one rating for a particular movie, that is 5 out of 5, that will get 5 out of 5 if you do just simple average. If there is another movie which has got a billion ratings, and if you average it, it's coming out to be 4 out of 5. So if you look at it, 4 out of 5, this second movie which has got billion ratings is more popular and most likely more correct than the one that is uh, the one which has got only one person reviewed it, which means that your formula for computing average has failed to provide the overall rating of a movie, right? Here you will build an average formula which can give a better ratings. So this is an example of what data scientist would do. He will build similar algorithm to give you the overall rating. Also, the data scientists do a lot of things, like for example, building a recommendation engine on top of your building an algorithm for recommendations as per your data. Okay, so that is the role of the data scientist. Yeah, so let's take a break and I'll address your questions after 10 minutes. Okay, let's take a break for 10 minutes and let's come back at 11:05. Hello, can you hear me? All right. All right, so I will be starting now. So let me try to answer a few questions. Okay. So yes, Aparna, relational plus EDW plus big data is the complete solution. Before that, can you guys hear me? Are you able to hear me? Good, good. So, Gorbara, continuing to your answer, your question, next question after the question of data scientist is what tools they are using only Hadoop. So they use a myriad number of tools. Okay, starting from R to Mahat to Graph to Giraffe to MLlib, and there are multiple multitude of tools they use. Okay, they as in data scientists. How will big data without EDW for analytics? Okay, so yes, it can definitely be used for EDW. Without EDW, it can definitely be used for analytics. Yes. How is it efficient or useful compared to cloud systems? So cloud systems, when we say cloud, okay, cloud cloud is basically when we say that it's a how do we compare it to cloud, it's like saying that how does laptop compares to the computer, right? So uh, big data solution runs on a cloud is nothing but computers located at somebody else's place, and what is running on their computers is absolutely either it can be independent units which is running on their computers on which is running on the cloud, or they might be running a distributed solution. Okay, so when you are running your big data solution, it could be running on the top of clouds. All right. All right. Hello.
Sandeep, you're on the podcast.
Okay, great, thank you. All right. Yeah, Aparna is right. So relational plus EDW plus big data can be considered as a complete solution for an enterprise. All right. Yep. So Srinivas's point is that can we conclude if there is a requirement to move a data center to big data, there is no new hardware requirement. That's very correct. All right. That's very correct. Now, so I'll be moving slow, answering everybody's question In case something is left, we can cover it in the next session. Don't worry. All right. Okay. Now let me just few questions. How is analysis of data saving money for the business? If you have gone through my, if you have just attended my previous slide, then you would be able to answer your question. So analytics saves money and analytics earns money. Like for example, we always at Amazon we have in place almost all the systems are well within A/B testing. Okay, what does it mean by A/B testing? We always have two sets of servers. So Amazon's website, if I open this Amazon's website and you open this Amazon's website, there are chances that you will see a different website and I'll see a different website. Why? Because for some users, they are running some different code. For another users, they are running a different code. Okay. So for A/B analytics is essentially running a new code only for few users. Okay. So let us say that one product manager says that why don't we put icon in the submit button, or buy now button can we put a blue color, right? This is a very minor change, but it is, if it is based on the analytics, if we do this only for few users, then we will be able to understand a, a better understand more about whether this is correct or not correct, right? So most of such decisions are taken based on the data. So any idea people come up with, they generally run it on a very small traffic, 0.1% of the total traffic, and then they see the response time. If it is going good, if people are buying from the blue color more as compared to red color, then they will keep on increasing the percentage of the users who should be shown the blue color as compared to the red one, right? So effectively, in a long run, if you have such kind of systems in place, like for example recommendations, so in case of Amazon or in case of other companies also, if people are buying more people are buying more based on a recommendation, it's definitely making money. All right. So there are multiple ways big data analytics can help you do a research. For example, before taking a product call, we need to figure out what are the browsers which our users are using. Are they using i7 maximum? Are they using tablets? Are they using computers? Are people buying from the laptop? Are they buying from the tablet more? So out of all of these framework, out of all the behavior of the users, we devise our strategy based on the data. All right. So examine our assumptions whether to build for this platform, that platform, this browser, that browser, all of the assumptions, or are people really buying games in India? That, let's say, you have to just validate that part. Okay, so you are building a solution for gamers, and first question is that are people really buying games in India? Now the only way to validate it is based on certain data. Okay, so there are enormous amount of assumptions before you build a product, right? And to validate those examples, the data is the only way to go forward. Okay, and all the sales and marketing strategies again need to be based on the data. If you have that much of data, if you have the user behavior of the geographies of various demographies, then you are in a good place, right? Similarly, you can use the big data or data to attain or retain your existing customer. You can do the A/B analytics, and similarly, you can do historical data analysis instead of surveys. The old old technique always had been, before launching a product we will do the survey. That is not something which works. Surveys are good, but surveys are not truthful. The data, the behavior of user is truthful. Okay. Let's say, I mean, survey as in you cooked the food, you invited all your relatives. Okay. At the end of the food, you ask them, how was the food? They said it was brilliant. Okay. Instead of that, if you just measure how much food did they eat, that will tell you better than asking them. Okay. In case they did not eat, more than a single bite. Okay. All they took was a single bite, and they all have written that it's a great food, right? So a survey doesn't. So I only want to prove the point that surveys are not a great way of analyzing your product or of analyzing the user behavior. A better way is to do a historical data analysis. All right. At Amazon, we actually stopped surveys to a very, very large extent. All right. And second way of answering this question is, what is the expense of big data handling? Right. As I told you, tools. So effectively, there's a lot of value the data brings in. Okay. Now, right. Now, let me answer Suhas's point. And so at the end of the day, data are structured using this, but data is still, yeah, it is completely up to you. It is completely up to you. For example, after churning 200 of terabyte of data, I came up with recommendations. Now, after I had the recommendations, the overall size of the file containing recommendations was hardly 2 GB. That I moved to the relational database, from where the conventional systems picked it and showed it to the user, right? So it's back and forth. It is not this or that. You always look at things from customer perspective and from the user usage perspective. And that is where the skill comes into play. Okay. To figure out what are the things you need to build. All right. So now next question which people ask me is, how important is it to the career in big data? So I did a very rudimentary analysis. First is that I went through Gartner reports. So for even this year, all top 4 points in the Gartner, uh, you know, top 10 technologies is big data. Similarly, Forbes top 10 tech trends, 5, 6, 8, 9 points are basically big data. Okay. Now, one is that. Second is that if you see based on the salary distribution, you can see that the people in the jobs which are there for Hadoop are far more paying than what is it in Java. Okay. So when it comes to 0 to 3 lakh, the number of jobs in Java are more. But when it comes to 6 to 10 lakh kind of a salary range, the jobs in Hadoop are more. So what does this data display? This data essentially that tells you that there is a demand and supply gap between the jobs, between the requirement and people available into domain like Hadoop. Okay. That is the reason why there is this gap in the salaries. Okay. So demand and supply, and moreover Hadoop is a little niche technology, right? Niche as in, for learning Hadoop, a person should have a background of handling some amount of data. It is not meant for freshers. Okay. So even if you have 1 year of handling the big data, or you have learned SQL, only then some of the data technologies will make sense to you. Okay. Also, from the number of jobs at Naukri.com and Indeed.com, Indeed.com is from US and Naukri.com is India, you can see that there are so many openings for Hadoop and big data. And this is increasing, this is not decreasing based on Gartner and Forbes. All right. Now we are going to start something like Hadoop. Let me answer Digvijay's point before that. So for all these e-tailers, big data is primary thing that they need to use or keep their portals busy and running. They need to use for keeping the portal. Yep. So for any retailer, so it is started with websites like Google and websites like Facebook and websites like Amazon has been the biggest user of the data, but it equally applies to the very small players, right? Therefore there are many small players in the market who provide the big data solutions to various companies. I was reading about the company called I forgot the name. So they are basically providing search to companies like eBay because they could not move quickly to the big data platforms. Okay. So not only retailers, almost everybody. All right. So let me talk a little bit about Hadoop. I'm not rushing into things fast. Okay. In case we leave something, we can anyway address it in the second session. Now, so Hadoop is basically created by dog cutting, and then joined Mike Cafferel joined him, and they basically doing a hobby project on building a search engine, just like that. It's not that they were not happy with Google; they just wanted to build another search engine. They were doing it part time, and that's the when they realized that storing data using traditional techniques is not working for them when their data starts growing. And luckily for them, Google published the paper on Google file system, Google compute engine, and Google database. Okay. And then they moved their all of the computing what for their search engine, and they implemented the papers published by Google, and they started calling it Hadoop. Okay. So and that is what they started using in Nuts. And the name, the yellow elephant, is basically based on the toy of the founder's son. Okay. Dog cutting son was playing with a yellow toy called Hadoop, and that's how the name comes. So, Hadoop is basically a framework to handle big data. Now, as of today, it is an umbrella of product. It started with HDFS and MapReduce. Now it's an umbrella of products. Okay, all of these products which lie in this umbrella are basically frameworks to handle big data, and are for, in other words, these are for reliable, scalable, and distributed computing. Note the keyword distributed. Okay, so that is what Hadoop is. Hadoop is basically started with these guys, and the first few components which were part of Hadoop were HDFS and MapReduce. Later on, more components kept on adding under the umbrella. All right. Now here is the architect. Here is the big diagram which shows you things. So first one is the Hadoop distributed file system. This is what is a file system? As you open your C colon, you see files and folders. That is file system. Okay. Under the hood, when you write some data into the file system, it goes and writes those zeros and ones into the cylinders of your hard disk. That is something hidden from you by your local file system. So the one which you see in your computer is a native file system. Similarly, Hadoop provides you a file system which hides the internal technicalities from you and provides you a smooth interface to upload the files and folders. Okay, so let me go into the details of HDFS. So Swadhin's question is, does Hadoop follow MVC patterns? So MVC patterns are good where you are building the application for the end user, specifically data oriented application where the application is to be written by the end user and you have to tell them follow this pattern. Okay, internally, whenever you are building a solution like as file systems, although you tend to use MVC like architectures, but that's not strictly that way. So if you look at the HDFS, you can think of the view, or you think about the native file system. View is a hierarchical structure, and model is basically I mean the logical structure of files and folders, while the controller converts it and puts it into the bits and bytes. Okay, so I mean it's actually difficult, but we don't use MVC in this sense. Okay, MVC is mostly a guidelines to the developers saying, ki, hey, write your program in MVC pattern that makes your life good and makes your product happy, stable. So Sunil's question is, to learn Hadoop, do we need to know Java? So no, my answer is no. As of today, you do not require only Java to handle. Don't need Java to use Hadoop. Okay. You for file system, you can have the command line. You have the browser-based file interface, and for compute engine, you can write programming in any language. And good news is that you don't require to write any programming for doing lot of computation. Both Hadoop has started providing you SQL as well as new language called Pig Latin, which is similar to SQL. Okay, so that is Sunil's question. So my answer is no. What are the layers named above the file system HDFS? You will have to hold on, Sudhindra, for a minute. I will talk about each one. All right. So I have half an hour more. I'll go into quickly into HDFS, and rest we can continue in the session too. All right. Now, if you have 100 terabyte of data, how would you store it? Okay, let me ask you, I want to, make sure that you understand why do we need Hadoop distributed file system. So if you have 100 terabytes of data, how would you store it? Okay, Swadhin says that we'll have to split it. Good point. How Hadoop maintains index. We'll talk about it, Ashish. Don't worry. We'll distribute it onto multiple hard disks. Good point, Shilpa. Next, what will you do? Bifurcate onto logical points into different data. Excellent, Srinivas. Utkarsh says storage boxes. Excellent. I would like to understand more about your storage boxes, Utkarsh. MSA is what? Multiple storage appliances. Okay, Digvijay says distributed systems. We'll talk about distributed later. Let's see what is the traditional approach. Okay, Ankit says that break it into small files of smaller size. Excellent. On data cluster that we can store. Okay, that was Swadhin. Yogesh says on data clusters. Sudhindra says, of course, in large capacity hard disk distributed. Sudhindra, I would like to understand more. That you are right. That's what I'm actually looking for. Using 100 systems with 1 terabyte each. Good, good, good. You are very close, Gaur. And Vikas says that we'll create segments and store data in that. Excellent. More details, Vikas. Utkarsh says MSA is a series of storage boxes which SP offers for data centers. Excellent. Yep. So good, good. So anybody else? Quick. All right, all right. So you guys all almost have answered what I have expected. Is if you have 100 terabyte data, how would you store it? This is how we did it traditionally. Okay, this is how we did it traditionally. All we did was connected hundreds of hard drives, okay, into a network. Okay, say five hard disk, eight hard disk on one computer, eight on another, eight on another, and so on, right? So we had like 15, 20 computers and so on, and built. And after we had connected these hard drives into the computers, we mounted. You understand the concept called mounting in network file system. So all of these hard disks are now visible in the network, and to make it logically at one place, we mounted all of these hard disks into a parent folder on one of the nodes. Now whenever we try to write into any folder, the call goes to that particular system and you start writing into that, right? Now we have got main folder, we have got drive 1, drive 2, drive 100, these folders which are basically representing the hard disks available in the network. Okay, does it make sense to you? This is what we build. NAS, SAN, or MSA looks like a similar solution. Okay, so do you think there are problems with this kind of structure? So let's say we have to store movies. We have to store 100 terabyte of movies. So we make a scheme saying all the movies starting with A go into the first one, go B go into the second one, C C8 to CU go to drive 3, CU to CZ go to drive 4, right? And so when we make this scheme and start storing the data, what are the challenges you're going to face? And say, like any network system, I say that each drive 1, is going to have one more backup drive on the same computer, which is RAID 1, where I have a copy of drive 1 on the same machine. Which means I have built 200 terabyte of the data, out of which 100 terabyte is just for the backup of other 100 terabyte. All right. So do you see any problem? Good. Aparna says IO traffic problem, input output traffic problem. Traffic is a problem in, yes, for the main folder, yes. Any other? Caching. Caching as in caching on what? Feel free to answer this question. There are multiple problems in this solution, and we all have faced it, but we didn't know how to actually solve it. Overutilization of few drives, which might lead to space limitation. Excellent point, Suhas. So yes, if your movies on A are too many, one drive might be full while other might be completely empty. The drives we allocated for Q might be completely free. Okay. So Ankit says that if you update one hard disk, updating the backup will also be required. Very true. But that is fairly solved problem by the way of RAIDs. So RAIDs basically make a immediate copy of the same data. All right. Performance issue. Good point, Digvijay. If the data is more, if the data is more for starts with A and its hard disk gets full, then what will be the solution? Very good point, Vikas. So we call it distribution of data is a big problem. Failover may not work properly. Very good point, Yogesh. If we have related data in multiple hard drives, okay, let Aparna complete the question. Okay, you mean to say caching will be a problem if we have related data in multiple hard drives? Is that you mean to say? How to find whether A is stored in drive A? That's a very good point, Shilpa. Data redundancy. Good, good. That is Sri Ramuli. That is Sri Ramulu. And yep, sharing the folder will be a problem, Seetal. And disconnection of that's a good point. And Smita is saying disconnection of drives. Very good point, Smita. So yes, we talked about backup of drive 1 on the local, but what about the disconnection? If that computer on which drive 1 and the backup of drive 1 is located, if that computer goes out of the network, or the computer shut down, OS problem, or any other virus problem, or any other problem like memory failure, CPU failure, or any other problem, then that computer is useless for you. You lost your data. At least right now you lost the data. Availability is not there of the data. Data is not completely lost. It can be recovered, but right now we can't access it. Resource underutilization is going to be a problem. Very good point, Srinivas. We'll talk about this. This is a very good point. Connectivity and complexity issues. That is Susma's question point. Yes, yes. The- and Utkarsh says space concerns, mirroring not good an option. Excellent point. Awesome. So you guys have given a really good, answers. Let me just reiterate in my own way. So we talked about failovers and backups. What about one computer goes out of the network, right? Second, how would we distribute the data uniformly? That was another problem, right? Third, is this the best value for money? We bought 1 terabyte hard disk, each 100, right? 1 terabyte is not a cheap hard disk, but 500 GB hard disks are really cheap as of today. Okay. So, is this the best use of money? Are you, or maybe in your organization there are already hundreds of drives lying around? Can you use those ones? Right? If you use those ones, then you'll have more computers, more nodes to manage, and more problems related to the distribution and failovers. Right? So, fourth problem is increased accessibility. Somebody said utilization, resource utilization. Srinivas said. And yes, what does it mean by increased accessibility? Imagine this: a new movie came in yesterday. A new movie called Penguins of Madagascar came yesterday, right? Now, all of your users who watch movie from your network, all of they will want to watch that movie, and that movie is located on a single computer, and all of these people are going to hit that computer, and that computer will choke, and eventually will be out of network. So even if there are 10 people hitting that node will die actually. All right. Because it's a same single hard disk, it's a single memory, it's a single network cable, and that's where you get stuck, right? So that is accessibility. Now, all right. Yes, Smita is saying we need to maintain the metadata. Yes, if you start maintaining metadata, you are essentially moving towards building your own your own file system, right? So that is solving these problem is what HDFS does. Now let's move on to what is HDFS about. HDFS essentially, so the lower section of this diagram, let's focus on. So the solution given in this previous one did not solve, and we need to use Hadoop distributed file system. A Hadoop distributed file system, if you look at this diagram at the lower section of diagram, it is basically representing a HDFS cluster. I'll go slowly one by one. So HDFS is built using two kinds of nodes. One is name node, other is data nodes. Name node is the master of the system. Okay, name node is the go-to guy for all the initial points. Okay, name node contains the all information about the file system. It maintains what is the file name, it maintains what is the folder names, and it maintains all other information. Now there is something called data node. So data node are the actual workers. Name node is only a singular node. In a whole HDFS, there will always be a single name node, right? It's like a manager and other are slaves. Okay, manager and other. I mean, you can say master and the slave. So name node has got a singular entity. Data node are the guys who are actually storing the data for you. Okay, they are storing the data for you. Okay, and they provide the actual storage. So they serve to your read and write request. Okay, so next point is that let me again go back to the screen. Can you see the diagram, Yogesh, now? All right. Now, actually storage is being done by data node, and admin node just keeps the metadata such as what the file permissioning, what's the files, and all the other information about things. Now, each file is divided into the chunks of how much? Chunks of 128 MB, right? And each chunk is stored on data node. So data node does not store the whole file as is, but the big file, if the file size is bigger than 128 MB, it is divided into smaller parts like 128 MB each, and those parts are stored on each data node. So if you have got, quick question, if you have got say 1 GB of data, how many parts will there be? 8 parts. Okay, so right now this chunk the default chunk comes as 128 MB each block. You can configure it to whatever you wish. Earlier it was 64 MB. Now, so even if you have 1 terabyte size file, you can store on this machine. If you have 2 terabyte size file, you can store on hard disks which are at least which are of very small sizes, 1 GB size, 2 GB size, 5 GB, 10 GB. Any hard disk will do for you because we are splitting the data into chunks or blocks. Okay, I'll be using chunks and blocks interchangeably. So first point was that we have master and slaves. Slaves store the data, master stores the information, metadata. And what kind of metadata? This data. Which block is on which data node is this information is stored on admin node or master node. We call name node, admin node, master node interchangeably. Okay. So your information, like where we talked about splitting the data into blocks, and this information that this file is split into these blocks, and these blocks are stored on this data node, that data node, and that fourth data node. All of this metadata, this is the metadata which is being stored by name node at a single place, while your actual data is distributed across the network. All right. Now, next point is that each block is replicated by default to 3 blocks. Okay, this can be configured per file basis and per and default settings also. But for discussion reasons, we'll just stick to 3. Okay, so each block will be copied 3 times on another machines. Okay, so let's say you have a file of 512 MB, which means you will have 4 parts. Yes, Sudhindra is right. Okay, for 1 GB you will have 8 parts. For 512 MB you will have 4 parts. So part 1 goes to data node 1, part 2 goes to data node 2, part 3 goes to data node 3, and part 4 goes to part. Just let's assume this part. Okay, now each of these blocks will be replicated onto another 2 machines to give the backup, so that any of these node fails, you have the backup. Okay, so that at any time any of these data node fail, you have the backup, because each block, and what is the block? Block is the 128 MB size part of your main file which you want to store on this. Say you have a movie of 1 GB, they will be cut into 8 parts, stored onto these data nodes, and each block will be copied onto these nodes, replicated on these nodes. Anytime the data node goes down, the parts which got lost due to data node uh, will have the copy anywhere, and those copies will be again copied to compensate for the loss. Okay, so a block A has got A1 and A2 as copies, and the moment the data node storing either A1A or A2 it goes down, the block will again the block A1 or A2 will replicate in order to bring three copies available in the network. Okay, if you have got very important file, highly accessible file, there's a lot of people wanting to access this file, you change or increase the replication level from 3 to more, and in case your data is not important, you decrease the replication level. Number of replication means number of copies available for a file. Okay, file is split into blocks. Blocks are stored on data nodes. Data nodes keep on copying these blocks for giving you the replication. All right. Now, if you add more data nodes, the blocks will move to rebalance the storage automatically. Similarly, in case any data nodes get lost, the replication from one data node to another will ensure that we have three copies of the data, three or whatever you have configured. All right. So that is what the HDFS is about. Yep. So backup of the data, Vikash, I'm answering to Vikas's question. He asked that can we backup the data from machine 2 in machine 3? Yes. It automatically backs it up for you based on multiple factors. What kind of storage available, how far is the other node, and this strategy, where will my backup go, is completely defined by Hadoop. Generally, one copy of the data is stored very far, while one copy is stored very close to the actual data. It is not manual process, God. This is automatically done by HDFS for you. It's a automatic rebalancing, unbalancing, and as you add more data node, it automatically moves some data to the newer node to balance for the traffic. Okay. Okay, so Sital's question is that should the block size and capacity of all data nodes be equal? So let me put it this way. If you have very small size of block, what will happen? Okay, answer me. So let's say we have block size of 1 MB. What will happen? What will happen is you will have for 1 GB you will have 1000 parts, which means too much of metadata, right? That means too much of metadata. Yes, number of files are going to be many. And metadata is handled by name node, which means name node is going to be overly loaded. All right. Now, so we talked about few things. First, file is split into blocks. Blocks are stored on data nodes. Or each block is copied onto another node to give the provide the backup. Rebalancing and compensation of the loss keeps on happening all the time on the HDFS. Okay, and that is what makes it so robust that you can uh, with the peace of mind you can manage a person can manage 100 nodes cluster very very easily, very very happily, which means 800 terabyte of cluster any of you or me can handle easily without any problems at all, without waking up in nights. Okay, now, okay, let me answer Seetal's question. Uh, so should the block size and capacity of all the data nodes be equal? Right, now if you look at it this way, if you increase the size of each block, what will happen is the movement of one block to another will become a big problem. Also, if you increase the size of block, you cannot utilize the small SD card or small hard disks to give you the storage, right? Therefore, your block size is, very arbitrary, and generally it is taken as 128 MB, because 128 MB is not too small and is not too big when we talk about transfer of the data. Okay, so, and block size does not need to be equal to the capacity of all data nodes, right? Block size generally is smaller than, far smaller than the smaller hard disk available. Okay, so smallest hard disk is generally has been assumed that will be 1 GB available, right? So so it's one fourth of the smallest hard disk available. So that's like saying that why do we have brick size this much? It is just very arbitrary, and it's not too small or too not too big. Okay, make sense? Was I able to answer your questions, Ethel? Okay, so Jaira's question is that, okay, I'll answer your question. Let me just complete few more things and I'll answer your questions. These are very important questions. And good, good. So now the other part is admin node keeps all the metadata into RAM as well as keeps a copy on the disk, which means all the metadata needs to fit into the RAM. The moment you start increasing the metadata, and your RAM is insufficient at name node level, what will it do is it will increase the size of the block to so that all the metadata can fit into the RAM. Okay, so that is something which admin node does as a magic to be able to handle any lots of files. Okay, now the next part is name node tries not to become the bottleneck. So when you read a file or when you write a file, let's say you are planning to write a movie, you do not hand it over to name node. Okay, you ask name node. When I say you means your driver as in command line or Java driver or whatever. Your driver will ask name node, hey, can you tell me where can I store this file? Name node in return, okay, you want to write, okay, let me make a note of it that you are going to write this file, and please go to data node 1 2 and 3, write your first block here, second block there, third block there, and your driver will split the file and write into the data nodes. All right, that's what happens. All right, now this is similar case is when name name node is trying to read the file. Okay, you are trying to read a file, you go to name node and ask, hey, can you tell me where is my file? Name node tells, block 1 is here, block 2 is here, block 3 is here, you can go to these nodes and get it by yourself and do not bother me, right? This way name node did not become did not, I mean CPU usage of name node did not increase, network usage did not increase. Okay, so basically name node saved itself from becoming the bottleneck. Okay, now all it does is you ask it the metadata, it gives you the metadata. You want it to store the file, it tells you that why don't you go and store the data by yourself, don't bother me. Okay, so that is one of the very important reasons why name node is able to survive. Otherwise name node will become the bottleneck. Name node is not the gatekeeper, it is just a token giver, it's a token distributor. Okay, when copying a file, I'm trying to answer Jairaj's question. When copying a file to HDFS, whether it is split into multiple blocks and stored across the data node, I think it is you got the answer, Jairaj. No? Good, good. So anybody else has this question? I think everybody got it. Utkarsh says that so we don't need to take a backup of HDFS. Like no, you don't need to worry about the backups. HDFS itself makes sure that it gives the backup. And third copy of each block is going to be stored as far as possible. Which means if you have two data center, the copies of one data center will be in another data center. So that even if your one data center burns down, you have the data in another one. Okay. So Seetal, was I able to answer your question? Okay. Seetal's next question is, can I have data nodes of varying capacity? Yes. One machine can be small, machine can be big without any botheration. Okay. Do we also replicate name node to help? Very good question, Abhilash. So name node has got something called backup name nodes. Okay. Or I mean, that is something which is done by a different distributor of Hadoop. Okay, so name basically it's like a hot backup of the metadata of the name node, and the moment the name node goes down, that takes a place. So Sunil's question is, how many name node can we have? There is only one name node is there, and I think you got the answer. Will the name node also serve as master backup storage, or is it a separate node altogether? So it is completely up. Okay, this is something very important, Srinivas. Let me just take a bit of more time. And so when I say data node, admin node, or whatever, all of these are basically processes running on your computer. Okay, if you run a process called data node on your machine will be happily accepting the packets from for storage. If you run name node, then it will become the name node, right? Now, so which essentially means that multiple data, I mean, you can run 10 data node on a single machine, although it doesn't make any sense, but for virtualization and experimentation reasons you can run multiple processes of data node on same machine but different port. Okay, similarly you can run name node and data node on the same machine, but it doesn't make much sense because admin node will become overly pressurized, and I mean it doesn't make much sense because it's overly loaded. And although the virtual machine you generally download from Hortonworks or Cloudera, they contain admin node and data node on the same machine just for that's just for learning purposes, not really true useful. Yes, you are right, Seetal. Yes, you can have data node 1 of 1 GB and data node 2 of 2 GB and so on, whatever you want. Okay. And that's why we say commodity hardware can be of various sizes, and as and when you get more hard disk you keep on connecting onto this network. Is there a cap limit of data nodes? No, right now there has been no limit on data nodes. All right. Okay, Ankit, there will be only one name node because name node also ensures sanctity of your data. No two persons will be creating or editing the same file at the same time. All right. Therefore, there cannot be more than one name node in any cluster. If there are more than one name node, there are effectively two different file systems. All right. If I am copying the file which is of less in size, will it split or store it? Yes. If your file is smaller than 128 MB, okay, then it will be storing, there will be storing in a single node as a single file. There'll be a single block about it. All right. Or if you have say 130 MB, it will be split into two blocks. First block will be in 128 MB and second block will be 2 MB size, right? Yes, it will create all of these blocks by itself. So Sheetal, I was able to answer your question. Yes, no, about that different sizes. Uh, all right, great. All right, so this is the diagrams which depict the same process which I have expressed, that your file system, the driver will go and store on the data node, and all of this happens. All right. Now, as part of Hadoop, these are the various other component. There is something called compute engine. Compute engine basically distributes the load across the cluster. Okay, and how does it do it? We can take it in the second session onwards. All right, and all of these components like HBase is the database, Yarn is a compute engine which makes it possible to do the computation on multiple computers simultaneously. Okay, and Yarn sends your computation to the data on each node rather than bringing the data to the computation. And it supports various kinds of tools such as MapReduce, Spark, and more for the computation. Okay, and HBase is one database which stores its data on Hadoop file system and uses MapReduce for churning. Hive. Okay, so we can talk about Yarn and compute engine in the next session. Okay, let me first answer your questions. Can I have a block size of 20 MB in one and 30 MB in another? No. Block size is uniform for the whole file system. Okay. One name node can only have one block size. Okay. Block size cannot have, it cannot be based on a data node, or it cannot be based on per file. It is per name node, the whole file system. Okay. Okay. Yes. Okay. Let me Can we change or configure? You can only change if you change or configure, it will be for the whole file system. It will not be for a single system. The block size I'm talking about. All right. Okay. So I'll just go through the various components, one sentences each, and then you guys can describe you. Okay. So basically, Hive is the SQL interface where you write your code in SQL, and that SQL gets distributed onto the whole yarn onto your whole yarn to give the output. So multiple computers will be doing the SQL processing for you. Okay, now there is something called pig latin. So Utkarsh, just give me 2 3 more minutes and we'll be done. Pig latin is similar to SQL, and any logic you write is basically simplified SQL, and any logic you write in Pig or Hive gets distributed all over the network on all the data nodes for the computing. Mahout is the one which is a library of algorithms for various kinds of algorithms which runs on these. Uzi is a workflow where it says that because in your project you will be having some part in Hive, some part in Piglatin, some part would be copying data from here to there, some part would be downloading the data. To chain it together, you use Uzi. And for importing and exporting data from structured sources, you use Scoop. And for unstructured data, such as from Twitter tweets or from Apache logs, you use Flume. Okay, sounds good. And all right, okay. The configuration in between or should be for the first time. Yes, that is Silpa's question. Hive is to convert big data into structured data. No, actually, Hive is to churn the big data, and Scoop will help you convert that big data to your structured data. Although Hive makes it possible to make it put metadata and make it look like structured data. It is actually, yes, you are fairly right in that. Hive does convert big data into structured data. You are right. How many nodes can a name node handle? Okay. If there are millions of data node, do we need? No. If it can handle, you know, big enough nodes. I have not checked the limits of, I'll go into limits of the system later point of time. So Mahat is basically library of algorithms such as recommendation algorithm, such as clustering algorithms, so that you can, like Gmail does labeling, right? So that algorithm can be easily built using Mahat. You feed your data, tell that this is social, this is spam, this is non-spam. All of that can be done using Mahat. So which are the top NoSQL database? So one of the NoSQL database is HBase and the other ones are Cassandra, MongoDB. MongoDB seems to be most popular out of it. All right. So that's what is components about. So though, I mean, if you sign up for the full course, okay, this was like a free session from No Big Data, and for the full course you will have to sign up for our classes. Second class onwards you can sign up for the 6th December onwards. Okay, the session is starting from tomorrow morning 7 a.m. You will have to buy this course to for rest of the things. The course is will it will cost you 18,747 rupees including taxes. This is after 25% discounts. Okay, so there are 33 hours class, 11 into 3. This includes everything. We have a cluster cloud in which all these components are stored. You can do hands on from anywhere. Okay, so all of the details, I mean, you can start the sessions from tomorrow itself. Okay, so you go to No Big Data and you look at our course, this Big Data and Hadoop course, and you can sign up. Okay, feel free to give me a call. That's my number at the bottom, or you can write an email to me. Okay, so all of our classes are online just like this one. Okay, and you can attend from home or you can attend from office. Okay, so if you have any question, just feel free to drop me a email or just give me a call on this number. Okay, any other questions for me? Okay, yes, you will all get the presentation as well as the recording of this session. I'll send an email to all of you quite, I mean within couple of hours after my recording is uploaded. And okay, let me see. Okay, so Swedhan's question is that Swadhin's question is what's the maximum number of data nodes of name? No, I don't know the limits, but we have I've seen clusters with more than 10,000 nodes. Okay, as of now they don't have put any other limitations. Okay, what is your second question, Swadhin's? Okay, okay. Is there a second session? Okay, great. Okay. Can we call? No, we can't call it name node as parent or data node as child because they are not really hierarchy. Okay. It's one to many relationship. Yes, there will be projects to be done in the training. Okay. And basically there are 2 to 3 projects which we do on small level first. First is doing a recommendation. Second is doing a sentiment analysis, and third one is of your choice. And in case you really are doing good, then we put you onto the real life project which we do with our knowledge partners. Okay. So Jaira's question is that, okay, Jaira's question is communication between job tracker and task tracker, data node and name node. So most of it happens over TCP/IP. So Swadhin's question is there any programming knowledge required to make career? Not really, not really. Okay. But it will pay you really good. I mean, it will pay you back really good if you just know any programming language. Okay. SQL is, I would recommend that SQL you should know, because most of the big data solution tend to provide you SQL kind of interface. Okay. Prerequisites, Digvijay, for this whole class, this whole course is: first, you should know a little bit about databases. You should know a little bit of command prompt or shell, because our cloud labs is on Linux, and you should know a little bit about Linux. That will make you more comfortable. And third is that, I mean, you should know how to copy file, how to download, upload file, how to log in. And third one is you should know a bit about any programming language. Even if you have done programming around 10 years ago, then also it's fine. Even if you've done programming during college, it should be fine. You should be able to handle it very well. Okay. So Silpa's question is, what is the role of a job tracker? Job tracker is just like the way we have name node in case of HDFS. Job tracker is also, you know, the when you want to compute anything, you hand it over to job tracker. It Job tracker is like manager of all the workers. Okay, that's a part of the, compute engine. We'll talk about it in the next session. Okay, so Smash point is that, are there any other batches? I think there are more batches. Let me have a look myself. So www dot no big data Hadoop. So okay, there is another one starting from December 21, 8:30 p.m. The one which is starting tomorrow is from 7 a.m. Okay, and yeah, all right. Yeah, 18K after discount. All right, and yes, do we have an evening class which will be starting? These are weekend classes. Please note, all of these classes are weekend classes, and after 6 p.m. we have this class from starting from December 21. Okay. Any recommended certifications? Not really required. You mean for prerequisites? Do I require any certification? Not really. Not really. All right. Okay. Any available? Yes, we provide our own certifications, but there are other companies also like Cloudera and Hortonworks. They also provide certification. Okay. And we provide certification in various format, such as we provide you a LinkedIn recommendation, we provide you a permanent link to the certificate, and if you wish, then we can send you a hard copy of the certificate also. All right, great. Then so all of you have other classes. Good, good. Yes, if you have submitted the form, I mean, while joining this webinar, you must have inputted your email ID, right? So I will send the presentation to that those email ID with which you have signed up. In case your email ID is different from what is mentioned, just drop me an email at sandeep@nobigdata.com and we will put those email ID correctly. All right. I'll be sending your certificate for first session to all of you later, maybe a couple of days later. All right. I'll be sending you this certificate for the first session. Okay. All right then. Great. Great to have you in the session and stay connected with us. We have just launched a forum where we will be answering all the questions and stay tuned with our nobigdata.com. We'll be very soon be having a lot of discussions over here. All right. So stay tuned with the website. And in case you really want to attend second session onwards, you can join us today tomorrow. All right. Feel free to give me a call at this number and at the email ID. Any other questions for me? Yes. These sessions will be only on the weekends. All right. Feel free to get in touch with me if you have any question. Okay. And basically we'll be providing you these kind of certificates, crawlable URL, as in if somebody searches you and the big data, you might they might reach to our website. Okay. Okay, thank you, Aparna. Thank you, Digvijay. And let me know if you want to go for session 2 onwards and you can attend. All right. And one more thing, this from session 2 onwards, we'll be using something called go to meeting where you can see each other's question. So I mean, I will not have to keep on repeating everybody's question, and also I will not miss out on the question, reading the question part. Okay, so that is one bit that makes the life easier. And there will be at most 20 people in the session. Okay, we already have 17 for tomorrow's class. There are only 3 seats left. Okay, so if you want, you can attend our sessions. And also, in case your company is sponsoring the course, in those cases, we do not forward your resume to the openings our other customers might be having. Okay, because that is considered like executive course. Okay, good. So there are a lot of knowledge partners who keeps on floating the vacancies. Your resume will not be sent there in case your company is paying for your training. All right. Feel free to get in touch with me and I would love to answer your questions. And if you have any doubt per se, just give me a call. All right. So this is the only session provided by us. We give this kind of session free of cost to all the all the organizations that have more than 50 engineers. Okay. So we do this session for free to almost all. Thank you, Raki. All right. Thank you, Ankit. Thank you guys. It was a very wonderful session. I really enjoyed it. You guys gave really brilliant answers. And feel free to stay connected. And if you have any questions, just drop me an email at Sandeep at No Big Data. And feel free to find us on Facebook also and write our review. All right. Thank you, Yogesh. Thank you, Shilpa. Thank you, Sudhirendra. Have a good day, you too, Digvijay. Bye bye. Yogesh, I'm happy that you like the session. Thank you, Abhilash. Have a good day. Thank you, Jaraz. Have a great day. Thank you, Ashish. Thank you, Rana. Feel free to get in touch with me. Bye bye, Digvijay. Bye bye, Aparna. Thank you, Suhas. Thank you, Madan. Bye bye. Have a great day. Thank you, Amish. Thank you, Swadhin. I also enjoyed the session. Good. Good. You really like the session. Thank you, Shundra. I'm happy that you found it nice. And thank you, Shushma. Thank you, Jairaj. Okay. Okay, guys. Have a good day. If you have any doubts, if you want to go for the tomorrow's session onwards, feel free to connect with me. Okay. Bye bye. Have a good day. I'm disconnecting now.